Hello everyone. In this video I will go over the review sheet for the exam 2. Here it is. It contains 30 questions and we'll try to go over all of them. I would recommend that you take a very good notes and also make sure that you try to solve these problems before you watch this video. Okay, so let us start. The first question over here is asking us to find the inverse of one-to-one function. Okay, so let's write that down. So we got, so question number 1. We got f of x equals to 2x plus 5 divided by 7. Now as you can see here, this is a line. And we know that line is a one-to-one function. And therefore we can find its inverse. Now the process goes as follows. First, you replace f of x with the y. Then you switch to domain and range, so y becomes an x and x becomes the y. Okay, so now we got a proportion. Let's cross multiply, so we get 7x equals to 2y plus 5. We need to solve for x, so we're going to move the y on the other side. And then just simply divide this by 2. And here we got our one-to-one function, which is 7x minus 5 divided by 2, which is answer choice D. Okay, let us go on. The next question is the variation problem, number 2. It says that if y varies directly as a square of x and y equals to 280, when x equals to 6, find y when x equals to 2. Okay, directly means that you can express y as a product of some constant multiplied by, it's a square of x. Well, that means x squared. So direct variation just simply means multiplying by a constant. Now, in order for us to answer the question, we need to figure out what the constant is. It says that y equals to 280 when x equals to 6. So we get 280 equals to k times 36. We solve for k, divide by 36. Let me grab my calculator. 280 divided by 36 gives us 70 over 9. Or you can also use a decimal. So then we get y equals to the constant, which is 70 over 9, multiplied by x squared. Okay, so this is our equation that gives us x as a, you can even call it a function of y. Okay, it says find y when x equals to 12. So when x equals to 12, you can go ahead and substitute that into x, and then I'll use my calculator and we'll see what we get. So 12 squared is 144 multiplied by 70 divided by 9. Okay, I got 1120, which is one of the choices, which is B. Okay, let's move on. Now remember, you can always pause this video and come back to the same problem slowly. Okay, number 3. It says the amount of water used to take a shower is directly proportional to the amount of time that a shower is in use. Okay, we need to write that down. So amount of water, A, is directly proportional to the amount of time. So let's do K times T. It says directly, right? Okay, so that means the more time you spend, the more water you will use. It says a shower lasting 16 minutes. 16 minutes requires 6.4 gallons of water. Find the amount of water used in a shower lasting 5 minutes. Okay, so that means we're going to solve for that constant first. Okay, so we're going to divide both sides by 16. 6.4 divided by 16. Okay. That gives us 0.4. So that means our equation for this variation is A equals to 0.4 times T. Alright, now it says find the amount of water used in a shower lasting 5 minutes. Okay, so we're going to put 5 in here. Oops. It's 0.4, right? Times 5 minutes. Well, 0.4 times 5 gives us 2 gallons. Okay, which is answer choice B. Now, the problems might also sound familiar as a basic proportion problems. Guess what? You can also solve them as a proportion, but that only would work if you consider the direct variation. Okay, if it's inverse variation, then the proportion will have to be used differently. So be careful. I would recommend that you solve the problem the way described here. Okay, now let's get to some. So this was, I think, stuff from chapter 1. Now let's get to our polynomials. Remember that majority of the chapter 2 is about polynomials and the theory behind it. Okay, so question number 4. A little arithmetic with the complex numbers. Okay, so we got 7 plus 2i multiplied by 4 take away 6i. Okay, so what does that equal to? Let's use the distributive property. Okay, so let's distribute the 7 first, and then we can distribute the 2y. Okay, so now we get, if you distribute the 7, you get 7 times 4 is 28, minus 7 times 6 is 63i, plus 8i, and then minus 12i squared. Okay, so let's see, you got 28 minus, what is it, 57, right? 357 I. Let me just check, minus, I apologize, so where did I make an error? Yeah, I multiply 7 times 6, it's got to be 42. Okay, sorry about that. Okay, so now if you change this, so we got 42 minus 42 plus 8, that gives us 34. Okay, so it's going to be minus 34i, and then minus 12 I squared will be negative 1, so it's 28 minus 34i plus 12. Okay, because I squared is negative 1, and then 28 plus 12 give us 40. So it's 40 minus 34i is the final answer. Okay, so watch out for your arithmetic. Don't make as silly errors as I just did. Okay, so this should be pretty straightforward. Let's go to question number 5. Question number 5, you need to divide the two complex numbers. So you got 7 minus 3i divided by 8 plus 6i. Now the only way you can divide the complex numbers if you change this in such a way that the denominator become real. Okay, so here's what we're gonna do. The way you do this is you multiply the denominator or the complex number that you're dividing by something that we call a reciprocal. A reciprocal would be 8 minus 6i. Whatever you do on the bottom, you also have to do on top. Okay, now let's go ahead and carefully distribute everything. Okay, so we're gonna distribute 7. So we got 7 times 8 is gonna be 50. We're gonna get 56. Then you get minus 42i. Okay, then you have minus 24. Minus 24i, and then plus 18i squared, right? And the denominator would be 64. Then you're gonna get minus 48 and plus 48i cancel out. and then you're gonna have minus 36i squared. Okay, now let's simplify more. So we got 56 okay, so I got 56, then 40 minus 42 and 24, that gives us 66, negative 66i, plus 18 times negative 1, correct? Okay. Okay, so then the denominator here will be 64 plus 36, correct? Because you have I squared. Okay, so then this is minus 18. 56 minus 18 gives us 38. So you got 38 minus 66i divided by, looks like 100. Okay, so then if we reduce this, we're gonna get 38 divided by 100 minus 66 over 100i. And that will gives us choice B if you reduce it, right? You will have 19 over 50 and minus 33 over 50i. Okay, we want to always leave our answer in the form A plus BI. That's why you needed to break it down on the last step. Okay, let's go on. So our next problem would be involving quadratic formula, isn't it? Yes. Solve the quadratic equation using the quadratic formula. Okay, so you got number 6. Okay. Okay, so we have 2x squared minus 5x plus 6 equals to 0. Okay, so let's use the quadratic formula. X equals to minus b plus or minus square root of b squared minus 4ac divided by 2a. Okay, so if we use the quadratic formula, minus b will be 5 plus or minus square root of 25 minus 4 times 2 times 6 divided by 2 times 2. Okay, so I have 5 plus or minus, okay, I'll use my calculator here. It's 25 minus 4 times 2 times 6. That gives me minus 23. The whole thing is divided by 4. Okay, so I'm getting the negative under the square root. So if I split this up, it becomes square root of 23 I, because I is the square root of 1, divided by 4. So let me just divide this thing by 4. Let me divide this thing by 4. And you got your answer choice, which is D. Okay, be careful with the arithmetic. When you see a square root of a negative, it becomes an imaginary. So you gotta attach an I in there. Okay. Number 7. Okay, you have Apple shoots an arrow upward into the air at the speed of 64 feet per second from a platform that is 24 feet high. The height of an arrow is given by the function. Let's write down the function. Minus 16t squared plus 64t plus 24. Where t is the time in seconds, and the question is, what is the maximum height of an arrow? Okay, so if we imagine what's going on over here, here we have the time axis, here we have h of t, which gives us the height at any given time. Now the arrow starts off when h equals to 0. This thing is at 24, is it feet? Yes, 24 feet, so it starts off 24 feet. Okay, so then you shoot it up, and eventually it's gonna come down. The question is to find this maximum height. Okay, so what's the maximum height? That is right there. Well, notice that this is right here is the parabola. And because it's a parabola, we can find a turning point. The turning point of the parabola can be found by the following little formula, which we derived in class. X equals to minus b over 2a. This is the x coordinate of the turning point. Okay, so if we now substitute that here, in this case, because we're talking about t as being our independent variable, so the t would be the same as here as an x. So we find like minus b over 2a, so it's minus 64 divided by 2 times negative 16. So it's going to be 64 over 32, right? Negative and negative will cancel. Okay, so 64 divided by 32 is of course going to be 2, right? Okay, times 2. So when it reaches 2 over here, that's when your parabola will be at highest point. The question didn't ask us to find when will that happen. The question is, what is the maximum height? So to find the maximum height, we're going to take 2 and we're going to substitute that inside that parabola. So I'm going to grab my calculator and I'm just going to plug that in. Minus 16 times 2 squared plus 64 times 2 plus 24 equals to 88. 88 feet, and that would correspond exactly to that location, and 2 corresponds to the time when that happens. Okay, so the answer is choice A. Alrighty, let's go on to the next problem. Okay, so the next problem is, okay, so it's about the multiplicities and the roots. So we got the polynomial, okay, already in the factor form for us, so that's nice. So you got minus x to the power of 3, then you got x plus 3 squared, and then x minus 9. It says, state whether the graph crosses the x-axis or touches the axis and turns around at each intercept. Okay, so it's about multiplicities of each factor. Okay, so first let's find the roots. So you're going to take each of those factors and you're going to set them equal to 0. Now note, this right here is also a factor. It has minus, well, minus can be thought as minus 1 times x cubed. Minus 1 is not going to do anything. What gives you root is the x cubed. X cubed equals to 0. That means x is 0. But note, the factor right here is just an x. You can think of this like that, x minus 0 to the power of 3, if you want to see it, you know, the traditional way. So the idea here is that that root has a multiplicity of 3, and therefore it's going to cross at that point, okay, as it reaches 0. Now here, if you set it equal to 0, this is more clear because you got x equals to minus 3, multiplicity is right there. So that's gonna touch. And the last one is just x minus 9. So you set that equal to 0. You get x equals to 9. Multiplicity is odd, just 1. So it crosses. So you get the choice C. It is crosses at 0. Okay. Touches at negative 3. And at 9, it crosses as well. That's it. Okay, let's move on. Number 9. Okay, use the leading coefficient test to determine the end behavior of the polynomial function. I'm not going to copy the entire function because to determine the leading coefficient, I need just the highest term. Okay, I need the leading coefficient. Okay, the leading coefficient here is negative 3x cubed. Now, note, you see, there are two things to look. One is that it's negative, and the other thing that it is odd. Okay, so let's look at this carefully. That is odd, so that behaves like our parent function x cubed. Okay, so what that means is that when x is very, very large, it goes up. However, you're multiplying by a negative, so thing is in reverse. So it is exactly like our parent, but instead of going up, it's going to do in reverse. It's going to go down as you go this way, and it's going to go up as you go to the left. Okay, there's another way that you could do it. You got to realize is that the idea behind the leading coefficient test is when the x's become, you see the x, when it becomes very, very big, or when it becomes very, very small, this leading coefficient will dictate what's going to happen. For example, look, when x is very big, let's say 100, look what's going to happen with that function. The leading coefficient will be minus 3 times 100 cubed, right? Now, imagine what that is. It's 100 cubed, so that is minus 3 times 100, and then we have another 100 and another 100. So it's minus 3 million. This is the idea. I hope you're getting this. That tells you that the number is very, very, very small. You see, that is why it's going down that way. However, when x is something negative, like negative 100, then what happens if you substitute that? You see, multiplying negative 3 times is going to give you a negative a million. A negative a million times 3 will be 3 million. You see, that's why it's going up this way. Okay, don't try to memorize it, understand it. Okay, so the answer here is the answer choice B. It rises to the left and it falls to the right. Okay, we're doing great so far. Let's go to question number 10. Find the zeros of the polynomial function and give the multiplicity for each zero. State whether the graph crosses x-axis, touches x-axis, turns around at each zero. Okay, in other words, we need to be able to factor this thing and then do the same thing as we did for the other problem, number 8. Okay, so let's do this. So I need to copy that first. So we got f of x equals to x cubed plus x squared minus 42x. Unfortunately, this one is going to be not too difficult to factor because it has a GCF, which you have to look for first. So you're going to take the x out. I'm going to left with the x squared plus x minus 42. Very common polynomial. And now let's factor this out. So we have the x, 7 times 6, and then that's a positive, and that's a negative, right? So 7 times 6 gives us negative 42, and the middle term, 7x, the outer terms is minus 6x, so that's good. Now if you set it equal to 0, here we're going to get negative 7, here we're going to get positive 6, and each of this appear only once. So multiplicity of each of them is 1, and therefore it's going to cross at every single root. Okay, that gives us the answer choice C. Okay, 0, negative 7, and 6, and it crosses at every root. Okay, number 11. Alright, determine the maximum possible number of turning points of the graph of a function. Okay, so first let's write that out. X cubed plus 6, 5x plus 7. Alright, now to determine how many possible turning points that can have, you gotta remember, number of turning points, that's where the polynomial would turn. The maximum number of turning points is n minus 1, where n is the degree of the polynomial. Is a degree. Okay, how do we find the degree? Well, you got to look at this way. If you're going to start distributing this polynomial, the largest term that you're going to get, which is what we need to determine the degree, will come from the largest terms in each factor. So x cubed is by itself. X cubed plus 6, higher factor is x cubed, and 5x plus 7, the higher term is 5x together with the 5. So when you multiply this out, the leading term, and you would also need to do something similar to that when you're doing the leading coefficient test, okay? So if you're given a problem this way, you first collect all the highest terms, and then you just multiply this out. X cubed times 5x gives you x to the 6 times x, so it's 5x to the power of 7. So we got 7 as our power, so that's our degree as well. So the number of turning points will be 7 take away 1, which is 6, which is answer choice A. Okay, number 12. We want to divide this using long division. Okay, so let's try this out. Okay, so we got 16, number 16, right? Okay, you had something like that on WebAssign. I don't think we divide this in class, but that's okay. Let's go ahead. 16 x cubed plus x squared minus 48x, take away 3. We're going to divide this by 8x squared minus 24. Right? Okay, now to divide this, it's going to be, even if you're dividing by something that is not linear, it's actually dividing by something of a higher power, you will divide much quicker. Look at this. You start with dividing with the largest terms, right? So we got 6x cubed and 8x squared first. Okay, so we do that. 8x squared divided into 16x cubed, we're going to get a linear term, right? So it's going to be what? 2x, right? If you don't see it, you can always do it on the side like this, and you'll see that this is 2x. You write it on top there. Then the next step, don't forget, once you divide it, then you gotta go ahead and multiply, but you're not just multiplying into 1, you gotta multiply this into 2. So 2x times 8x squared gives us 16x to the third, and then 24 times 2 will give us minus, okay, we're not gonna have what is it, we're getting a cubed, and then we're getting a linear term, so it's going to give us minus 48 x, right? So minus 48 x. I'm going to write it underneath its like term. Okay, so 48x. Okay, so now what I have to subtract, so that will be minus, and this will change to a plus. Okay, so that cancels. Well, that's nice. That also cancels. And then we're going to drop down what we have. So we got x squared, and we have minus 3. So it seems to be we're getting some remainder right here. Okay, now we're going to divide again. And are we getting here a fraction? Well, let's say x squared divided by 8x squared. Yeah, we're getting an 8th. Alright, so we're going to write it right here. Alright, so 1/8 now distributing gives us 8x squared. And then 1/8 times 24 gives us, oh nice, it gives us minus 3. So it's actually completely divided with no remainder. No, that wasn't expected. Okay, perfect, perfect. All the choices don't have remainders. Actually, they do. Choice A and D have remainder. This one doesn't. Okay, it's a pretty complicated problem. What made it complicated is the fact that you're dividing by something that's higher than linear, and also we had to deal with some fractions. Okay, but that's the way the long division is done. Let's go ahead. You might have simplified that before. No, it's okay. Alright, so let's go on to the next problem. So here the answer choice is C. Alright, so what else we got? Number 13, using synthetic division. Okay, synthetic division is more pleasant. So number 13, to do the synthetic division, we're going to write all of the powers, all of the coefficients in order. So we have -4, we have -28, we have -21, and we have 18. It's a third degree, so you expect to have 4 terms. And you're going to divide this by whatever makes the denominator 0, which is -6. Okay, so you're going to drop down the first term. Then you're going to multiply. So first you drop down, then you multiply this times this. That gives you 24. Then you combine. That gives us what? Minus 4 again. So that gives us 24 again. That will give us 3 because we add once we put together. Once we multiply. So that's 3. Then we have negative 18. Oh, how nice. The last one is the remainder of 0. Okay. So now if we write that down, we're going to transform that. Now how does this work? Original one had minus 4x to the third. You see, it was a third degree. It was third degree. So what happens here? This, because we divided by one factor, this is going to be of degree 1 less. So instead of x cubed, you're going to have x squared. Minus 4x squared minus 4x and then plus 3. Just like that. Once again, you see, you're looking at the degree of this. The degree of that is going to be exactly 1 lower. Okay? Alrighty, so that's choice B. Okay, oh, we have another syntactic division problem. Okay, this one has a 5th degree polynomial. Okay, so number 14. It's a 5th degree polynomial. Okay, so let me write that down. X to the 5th plus x cubed plus 1. And we're dividing this by x plus 3. Okay, so now notice, this is a 5th degree. So that means it's going to have, it should need to have 6 coefficients. So let's carefully write them all out. So we got first one, 1. X to the 4th we don't have, so it's going to be 0. So this is going to be the 5th degree. This is the 4th degree. The 3rd degree is 1. 2nd degree we don't have. 1st degree we don't have. And then the constant is 1. So you got 1, 2, 3, 4, 5, 6. 6 coefficients. You see it? The one that were missed at the beginning in the original polynomial, we're putting zeros for that. Okay, and we're going to divide this by whatever makes this 0, which is our root, right? So we're dividing it by minus 3. Let's go ahead carefully. I'm going to drop the 1, multiply, gives us minus 3, add minus 3. Negative 3 times negative 3 gives us 9. We get the 10 and get minus 30. You get minus 30 here. You get now 90. And then we're getting negative 270. And then we add, we get negative 269. That's our remainder. Okay. So then let's transform this. It was 5th degree. So now it should become the 4th degree. So it's going to be 4 minus 3x cubed plus 10x squared minus 30x plus 90. And then minus 269 is our remainder. We're going to divide this by our factor, which is x plus 3. Okay? Which is choice A. Okay? So it's going to pretty long, but, you know, very doable. Just do it step by step. Okay, so let's see. What is the next question it's asking us? It says, use syntactic division and the remainder theorem to find the indicated function value. Well, look, let's first think about that. Function value. How do we find the function value? We can just substitute negative 2 inside. So I'm going to just use my calculator, okay? And again, I'm telling you, you should have a scientific calculator to do function evaluation, okay? You do not do the things by hand in our class. Otherwise, you're going to make silly errors. So we got minus 2 cubed minus 6 minus 2 squared minus 3 times minus 2 plus 15. Okay, so now I this is not an arithmetic class, so I'm not gonna waste time and sort of going through all of the sign numbers. I'm gonna just put it all in a calculator the way I see it, and my calculator will give me the answer. Okay. I get negative 19. I'm done. Okay, well, this is not using the factor theorem, but that gives us the result. Now, how does the factor theorem works? The factor theorem says the following. If you're going to take your polynomial, okay, which is the original one, I don't want to copy it, just the way it was original. And if you're dividing it by the factor that gives us minus 2, which is x plus 2, then the remainder that you would obtain will be the same as the functional value. Okay, so what that means is that if I'm gonna perform a synthetic division, which is 2, negative 6, negative 3, 15, if I take those coefficients and I'm gonna divide it by, you know, x plus 2, which is my factor, and minus 2 is my root, like that, the one that was originally given, what I get at the end right here, what I get my remainders would be the same as the functional value. So this should be negative 19. So now if you just, you know, bring down the 2, then you get minus 4. Here you get negative 10. Then you get the 20. Then you get 17. Then you get minus 34. And minus 34 plus 15 gives us minus 19 as expected. You see it? Minus 19. So this is the idea. Is when you're taking a polynomial and synthetically divided by a given number, then the remainder you would obtain is actually functional value that is there, which is a pretty interesting theorem. So in this, it's a choice D. Okay? Let us continue with this. Okay. So we've done half of the review so far. Okay, next problem, number 16. It's a solid equation, 3x cubed minus 28x squared plus 69x minus 20 equals to 0, given that 5 is a 0 of the polynomial. Okay, so if we know that x equals to 5 is the 0, right away we know that x take away 5 is a factor. Now we have a choice. We can either long divide it by that factor, or we can divide it synthetically. I'm going to take this and divide it synthetically by that to know what the other factors are. Okay, once I know the other factors, I can then find the other roots. Okay, so I'm going to take my polynomial and divide it synthetically. So 3 minus 28, 69, negative 20. I'm going to divide this synthetically by 5. So bring this down, now multiply, gives me 15. Okay, so 28 minus 28 equals to 15. Oh, minus 28 plus 15 will give you minus 13. Now minus 13 multiplied by 5, that gives us 65. That gives us 4, and that's 20. Okay, good. We knew that it's going to be 0 because it says that 5 is the 0. Okay, so it means that this is 3x squared minus 13x plus 4. Okay, so that means that this is your polynomial after the division. That other factor, you can write it or you don't have to, you can leave it like that, is going to be x minus 5. But this is the one that gives us the new root. So from here, you can either factor it or use the quadratic formula, up to you. Okay, so if I try to factor this, I need to check the discriminant, of course. So b squared minus 4ac. So that's going to be 169 minus 4 times 3 times 4. Okay, and if I do that, I get 169 . 169 minus 4 times 3 times 4, that gives 121, which is a very nice perfect square, right? Okay, so I should be able to factor this. So we got 3x, and we got x, and now let's say we got minus 4 plus 1. Oh, it should be negative, both of them negative, right? Okay, so minus 4 minus 1, so that gives us minus 12 minus 13. Okay, perfect. So then if I set each of them equal to 0, we got 3x equals to 1, so x equals to 1/3. Here x minus 4 equals to 0, so x equals to 4. So along with our root of 5, we also got 1/3 and a 4, so these going to be the solutions to that third degree polynomial, okay? And also over here, if you use a quadratic formula, you would get those two roots as well, okay? You don't have to factor, you can just use quadratic form. Okay, number 17, that doesn't require you to do lots of algebra. That's just simply asking you to list all possible rational zeros for the given function. So that is just the ratio of p to q. Okay, p are the factors of the last term of a constant terms, and q is the factor of the one that in front. Okay, so the factors of 8 are plus or minus 1, so that's your p, plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. Factors of q are plus or minus 1, plus or minus 2. Now if you do it the ratio p to q, so first you're going to take this and you're going to divide it by plus 1, so you're just going to be the same. And then you're going to divide this whole thing by 2, so you're going to get plus or minus 1/2. Plus or minus 1 we already had, plus or minus 2 we already have, and that plus or minus 4 we'll also already have. So in other words, it just brings us a new factor of plus or minus 1/2, which is the answer choice B. Okay? It's a ratio. That's it. It's a ratio of P to Q. Okay, number 18. Find a rational zero of the polynomial function and use it to find all the zeros of the function. So first we're not given what one of the roots are, so we have to go through the P over Q ratio, find what the root is, one of them, and then go ahead and find the others. Okay, so number 18. Okay, let's copy our polynomial. So we got f of x equals to 2x cubed minus 9x squared plus 7x plus 6. And then we're going to do the ratio of p to q. Okay, so p is plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Okay, q is plus or minus 1, plus or minus 2. So p over q would be, first is going to be the same as p, because 1 is a factor. You always get the p as your potential roots, but the others will come from taking this and dividing them by 2. So you're going to get plus or minus 1/2. Then plus or minus 1 we already have, plus or minus 3/2, and 3, right? Okay, that we already have. So I would start with, whole numbers, and then I'll go from there. So if I try -1, that's not gonna work. You can check it for yourself. You can, let's try the 2, and believe 2 will work here. Okay, so if you put the 2, you're gonna get 2 times 2 to the third minus 9 times 2 squared plus 7 times 2 plus 6. Okay, and then that gives us 2 times 8 minus 9 times 4 plus 7 times 4 plus 16. Let me see. plus 6, I'm sorry. Here, plus 6. I put the wrong thing. 0. Okay, good, perfect. Okay, so 0 is the root. So now we can go ahead and, because it's a root, once we find one, we can find the other. So we're going to take our original polynomial. We're going to write its coefficients, which are 2, -9, 7, and 6. And we're going to divide it by the root that we just found, which was 2. Now remember, once we do the synthetic division, we should see that the remainder will be 0. So we drop down the 2, we multiply, we add, multiply again, add, multiply, add, and you see remainder is 0, so that means we found the right root. Okay, so now our polynomial breaks down into 2x squared minus 5x minus 3. Again, a nice quadratic polynomial. We can set it equal to 0. We can factor that, 2x, x. So let's see, it's going to be x minus 3, 2x plus 1. Right, so it's minus 6x plus 1, that's good, equals to 0. So the other roots are 2x plus 1 equal to 0, x take away 3 equals to 0. So you have 2x equals to -1. Divide both sides by 2, so that's our another root. And here's x equals to 3. So where are our roots? Remember, this is the one that you found originally. And this is another one. And here another one. Okay? Perfect. Okay, so these are the roots. Go over this problem. Make sure you know how to solve it. Okay, now number 19 is similar, but this one we will also have to go through the potential roots to try to identify what's the root of the polynomial. Okay, so number 19. Alright. So you have f of x equals to x cubed plus 8x squared plus 25x plus 26. We go through the potential roots. This one will have a lot because we doing 26 is a pretty large number. The good thing is that the q is only plus or minus 1 because there's no coefficient there. Well, the coefficient there is 1. So 1, 2, what else is 26 divisible by? 13. Actually, not that many. Yeah. Okay. So let's check them out. If you try 1, -1, +2, they would not work. The one that does work would be -2. Now, I'm skipping few steps. You have to go through and see it for yourself, and you shouldn't check that -2 will eventually work. Okay, so once you find that out, then let me just show you that it is. If you substitute -2 inside here, you'll get 0. You can check it on your calculator. And then, to demonstrate that it works, I'm going to actually go ahead and break this polynomial by doing synthetic division. When I'm doing synthetic division, I'm always dividing by the root. When I'm doing the long division, I'm dividing by the factor. Keep that in mind. Okay, so my coefficients are 1, 8, 25, 26. You bring down the first number, it becomes 1. Multiply, -2. Add, 6, -12, 13, and here we go. The remainder is -26 here, the remainder is 0. Okay, so polynomial what we're left with is x squared plus 6x plus 13. We're going to set this equal to 0. It's not factorable, you can see it right away. 13 is a prime number, so there's no way you're going to get a 6. So then you have to use the quadratic formula. So it's going to be -6 plus or minus square root of 36 minus 4 times 1 times 13 divided by 2 times 1. Okay, so it's -6 plus or minus. Okay, let me grab my calculator. So it's going to be 36 take away 4 times 13. That is -16. Oops, we're getting complex numbers. Dividing them by 2. So that will be minus 6 plus or minus 4i divided by 2. Now let's break that down. We get negative 3 plus or minus 2i. Right? If you split this apart. So that gives us the answer choice of, what is it? C. Choice C. Which is you got negative 2 plus 2 more roots. Okay, number 20 is somewhat challenging. It's a hard problem, but the idea is to demonstrate how it works. Okay, it is a harder problem that you can expect, but the idea here is, interesting. Okay, so let's go ahead. How do we solve this problem? Okay, the complicated part here is that the f of negative 3 got equals to 60 for question number 20. That's what makes this problem complicated. So let's see if we can figure this one out. Okay, if I were to ask the question like that, I would not put that as a multiple choice. Okay, so you wouldn't have to worry about things like f of negative 3 equals to 60. Okay, so let's go ahead and actually do this. Okay, so I know that this is the degree of the polynomial is 3. Okay, so it's question number 20. So it's a cubic polynomial. I know that one of the roots is negative 4. The other root is I. But that's only 2. We need another one. Well, if you remember, complex roots always come in pairs. So if there is I, there will be negative I as well. So then our roots will be x plus 4, x minus I, and x plus I. These are the roots, okay? So then our polynomial, and here's the tricky part. I don't know whether it's going to have any constants in there involved. So here's what I'm going to do. I'm going to put an a as a constant to be determined because I don't know what it is. Then what I'm going to do, and bear with me here, you're going to just multiply the rest factor as we did in class, just like that. Then I'll just keep going. First I'm going to multiply this complex pair so I can get a normal polynomial. So with the real coefficient, it's going to be x squared, and then what is it? Minus ix plus ix cancels out, so it's going to be minus I squared. Let me take one more step. X plus 4. I squared is negative 1, so it's going to become x squared plus 1. Next, what I'm going to do, I'm going to multiply these polynomial. I'm going to keep the a, so it's going to become x cubed plus x plus 4x squared plus 4. Okay, now let me write that in the descending order. So x cubed plus 4x squared plus x plus 4. Okay, now the question is, what would be the leading coefficient, right? Okay, the problem is that I don't know what it is. Therefore, I have to use this condition that f of negative 3 equals to 60. Oops. Okay, so what does that mean? That means if I put negative 3 inside, I'm going to get a, and I'm going to have to plug it in. So it's going to become negative 3 cubed plus 4 times negative 3 squared plus negative 3 plus 4. Okay, let me put that in. So negative 3 cubed is minus 27 plus 4 times 9 minus 3 plus 4, correct? So I'm getting 10. Okay, so it will be a times 10, and that needs to be 60, you see? That's the difficult part, okay? So they gotta be 60, and then because of that, a is forced to be equal to 6. Okay, so if a is 6, then I know that f of x has to be 6 multiplied by that polynomial x cubed plus 4x squared plus x plus 4, which is right here. So therefore, the answer would be answer choice A, which is 6x cubed plus 24x squared plus 6x plus 24. Okay, so that's the result. Okay, so this is a hard problem. I would say the hardest one. Well, what makes it hard is the fact that you got to carry this A around. Do you expect that I'll ask something like that? Might not, but what you do really need to be able to do is this part. Okay, that is mandatory. You really need to understand that, right? If something is a root, then you got the factors, you can FOIL it all out, multiply it out, and you'll get the polynomial. Alright, now number 21. Okay, Descartes' rules of signs, it appears over here. I'm not emphasizing it, so I'll just quickly go over it. I'm gonna just look at the sign variations, okay, quickly. So we got f of x, 6x to the fifth minus 4x squared plus x plus 4. How many sign variations you got? This is the only one. Okay, so there's one. Oh yeah, and then is there another one? Okay, so we got, let me check it out. Okay, so that is one sign variation, but then, so let me just do it carefully. So it goes, look, this one is plus, right? So I gotta be careful. From plus to minus, that's a sign variation. And then from minus to plus, that's also a sign variation. So there are two variations, so that means you can expect to have two positive zeros or none, because it's either equal to the number of sign variation or smaller by exactly an even number. Okay, so two positive or none. Then we're gonna do 2 of negative x, f of negative x, so it gives us negative 6x to the fifth. Then that will stay the same, because when you're putting a negative and you square it, it's gonna stay the same. That will be minus x, and that will be plus 4. So the sign variation here is just there. So it's one variation, so it's one negative root. Okay, which will give you a choice D. 2 positive, 0 or none, and then you have one negative root because there's one change of the sign in f of negative x. Okay, let's go on. Number 22. Let me just scroll this down. Okay, number 22. Number 22, you have h of x equals to x plus 7 divided by x squared plus 36x. Now this question is asking you to just find the domain, not the asymptotes, just the domain. So the domain here, because it's a rational expression, is that the denominator cannot be equal to 0. So if you factor the x cannot be equal to 0, and x cannot be equal to negative 36, okay, which is answer choice A. Just simply a restriction in the fraction. And here we go, now the vertical asymptotes. Okay, find the vertical asymptote if any, and then it says graph the rational function. Okay, so this one, let's see. Well, let's do that. Let's produce a graph, even though there will be a few other problems, just like asking it to graph them. So h of x is x plus 1 divided by x squared minus 1. Well, if you need to find the vertical asymptote, you need to first simplify your fraction. You see, the domain of this is that x doesn't equal to 1 and x doesn't equal to minus 1, right? Because you can't divide by 0. But that gets reduced. So then basically, the only thing that you're looking at is this. And this has a vertical asymptote when the denominator equal to 0 in a simplified form. So this is it. X equals to 1. So on the graph where you have 1, you're going to have a vertical asymptote. Okay, and this is going to be just a normal hyperbola because it comes exactly from the parent, right? From 1 over x parent, the one that looks like this. And then there's a shift 1 unit to the right because you have x minus 1. Okay, so here we go. The answer choice C is correct. Remember, you need to simplify first. Okay, let's flip the page. We got question number 24. 24 asking for the horizontal asymptote. I'm not going to copy the problem. Here you just look at the leading term. So the leading term on top is 3x squared. The leading term on the bottom is 2x squared. You simplify that. And your horizontal asymptote is right here. Y equals to 3 over 2. Okay? If the denominator had a higher power, then the asymptote will be y equal to 0. If the numerator has a higher power, then you do not have a horizontal asymptote. Okay, question number 25. Okay, let's discuss how do you find the slant asymptote. Okay, and then it says, yeah, just find the slant. Okay, so let's talk about this. So we got f of x equals to x squared minus 3x plus 2 divided by x plus 5. Now look, guys, here you got second degree. Here, basically, you have first degree. So degree of the top is higher than degree on the bottom. Now what does that mean? It means that I do not have horizontal asymptote. However, what there is true is that this function, when x has become very big, something can happen. Here's what I would like for you to show you first. Okay, what we're going to do is we're going to take this polynomial right here, and we're going to divide by this polynomial right here, using either the long division or the regular division. Now, since we have seen plenty of synthetic divisions in class, let's maybe just do one that is a long division. Okay, so we're going to divide. This goes in here, x, and you get x squared plus 5x, and this right here becomes negative. This right here becomes negative. Then you subtract, put them together, so it's minus 8x. Drop down to 2, divide it again, gives you minus 8. So it's minus 8x. Take away 40. Then this changes the sign, becomes a plus. It becomes a plus. So the remainder right here is 42. So we write that as a remainder over the divisor. Okay? So what does that mean? Let me just write this out so you can see this very well. The original problem, our original function, x squared minus 3x plus 2 equals to x plus 5, simplified into the following. It became x minus 8 plus, it's not a simplification, you divided it, right? You got this. X minus 8 plus 42 over x plus 5. Now note, when you did this part right here is now having a denominator which is linear, while the top is just a number. That is the constant. Look, when x becomes very big, right, very big, both positive and negative, what will happen is that this part right here, this will become small, very small, mathematically very close to 0, because look, when x is, let's say, 100, just an example, then you get 42 divided by 105. You see, this is small. But what if it's 1,000? Then it's 1,005. 42 divided by 1,005 is practically 0. And the bigger the x is, the closer the fraction is going to become to 0. However, this part right here will stay as x minus 8. That will not be affected. It's not going to become 0. It's going to keep getting larger. So here's the thing, which you need to understand. When you have a rational expression, and you see that the power on the numerator is exactly 1 degree higher than the power in the denominator, exactly 1 degree, that's when you perform the long division. You're going to obtain the polynomial, which is linear. In other words, it's a line. And the remainder will tend to 0. This what I highlighted, x minus 8, this right here. We call this a slant asymptote. Slant asymptote. What does that mean? That means when x is becoming very large, this function gets closer and closer to the line x minus 8. Okay? So this is it. This is how you find the slant asymptote. You just need to long divide, and the answer that you get before the remainder, that is your slant. Okay? Here's another question that I want to show you. Number 27. So let's skip 26 for a second. And let's just focus on 27. You see number 27? This is asking us to graph the function. So this is what I would like for us to do. Let's take that x squared minus let me erase that. Minus x minus 42 divided by x squared minus 1. Oh, that's not that one. I'm sorry. Number 28. 27. Number 27 has both top and the bottom same power. I want the example where the power on top is exactly 1 degree higher than the power on the bottom. So f of x is x squared plus 4x, take away 6, divided by x minus 6. Now look at this once again. You see the power here is exactly 1 degree higher. Now it doesn't have to be x squared and x. It can be x cubed and x squared, or x to the 5th and x to the 4th. Okay, but for the practical purposes, because we would like to graph them, the powers will not be too high. Okay, alright, so here's what we want to do. To graph a function, let's go through the steps that we talked about in class. First, let's go ahead and try to simplify this if it's possible. Okay, now if I look at that, if I try to factor this guy right here, I think I'm not going to be very successful, because I can try 3 and a 2. One of them has to be minus, the other one plus. That's not going to give me the middle term. You can try minus 6 and 1. That also doesn't give you anything. So it's not really factorable. Also, look at the discriminant. The discriminant is a 16 minus 4 times minus 6. That's 16 plus 24, which is, what is it? 40, right? 40 is not a perfect square. So you don't expect this to be factorable. Okay, so that means it's in a simplified form. So let's follow the step. Let's start first with the step 2, because step number 1 doesn't give us anything simplified. Let's go ahead and find x and a y-intercept. Okay, let's start first with the y-intercept. How do we find the y-intercept? This is the easiest one to find. Just substitute 0 and you get negative 6 divided by negative 6, which is 1. Now let's find the x-intercept. To find the x-intercept, we need to set this thing equal to 0. Well, we already did part of this work. Well, let me just slow down. For the x-intercept, you have to take the entire thing and set it equal to 0, right? Y equals to 0. But we discussed this in class. In order for a fraction to be equal to 0, we only set the numerator equal to 0. And then we solve. So you get negative 4 plus or minus square root of 64 minus 4 times minus 6 divided by, oops, I wrote 64, 16, right? I did it on top over there. Divided by 2 times 1. So it gives us minus 4 plus or minus 40 divided by 2. So then I'm going to grab my calculator and I'm going to find my 2 roots. So it's minus 4. Take away square root of 40 divided by 2. And minus 4 plus square root of 40 divided by 2. So, minus 4 minus square root of 40 divided by 2 is negative 5 1.2. Oops. And negative 4 plus square root of 40 divided by 2 gives me 1.2. About, okay? This is approximations. Because I need to plot this, remember? Okay. Now let's go ahead and look for... What are we looking for? For the asymptote, right? Now, what about the vertical asymptote? So step number 3. Vertical asymptote, you just need to take the denominator and set it equal to 0. So that's 6. Horizontal asymptote, well, once again, x squared plus 4x, take away 6 over x minus 6. The degree here is bigger than here. Therefore, it has no horizontal asymptote. However, you can still have the other one, which is the slant, exactly because the degree on top is exactly 1 degree higher. Exactly 1 degree. Cannot be more. If it's more, you do not have a slant. So to find the slant asymptote, what you do the division. So we can do either long or short. It's synthetic, right? I'm going to do long division here. So let me take x squared plus 4x minus 6. Let me divide this by x take away 6. So it's going to give me x squared minus 6x. I'm going to subtract here, going to add there. So it gives me 10x, take away 6. That gives me plus 10. And I don't really care about the remainder, because what I'm caring is the what's the asymptote is. So the remainder is 54. Your asymptote is right here. This is your slant. Okay, so y equals to x plus 10 is your slant asymptote. Okay, let's see if we can graph this thing. Okay, now this will be pretty challenging to do, but let's do it. Let's put all of the pieces together. Okay, so let me see. What do we have right here? We got, let's see. Here we got our roots. Let's start with that. And then intercept. 0, 1. Okay, we have minus 5. Something like minus 5.5 and 1.5, right? Yeah, minus 5.5 and 1.5. Okay, so 1, 2, 3, 4, 5, 6. So something like that. Minus 5.2 and 1.2 somewhere around here. About, okay? Don't have to be exact. And this is going to be, this one is 1. Alright, now we have an asymptote. The asymptote is at, vertical asymptote is at x equals to 1. Okay, so this is pretty close to here. So the intercept is a little bit after the asymptote. Okay, we did not have a horizontal asymptote, but we have a slant. How do we graph a slant? That's a graph of a line. So 0, 10, 1, so 0, 10 is going to be somewhere here. When x equals to 1, the asymptote here would be 11. So it's going to go through 11 right here. Then it's going to be 12, 13, and so on. We graph it as an asymptote. So with this dashed line. Okay. Then what else do we need to know? We need to know where does the asymptote crosses that, but that's going to happen at minus 10. Okay, so something is shaping. Okay, let's see what can we do. Now we know that the graph is going to start approaching the asymptotes, right? So let's see how it's going to look like. Oh, hold on a second. I think there's something is not right, right? And I believe that would be the fact. Let's see. let's check this. Okay, the vertical asymptote is x equals to 6. I'm drawing here x equals to 1. Here we go, because it's just something is not shaping up. Okay, so let me erase this right here. Okay, and we got x equals to 6. Okay, so 2, 3, 4, 5, 6. So here we go. Okay. So that means this point right here gotta be when x equals to 6. That would be 16. Okay, so now here's what happens. Whenever you have a slant and you have a horizontal, vertical asymptote, it creates sort of like quadrants, but these quadrants are not all at 90-degree angle, right? So here's like quadrant number 1, right? So it's like this area right here. Then this area right here, this is 2. This area right here is 3. All of this stuff right here, and then the 4. This is that. Let me just remove the what I just drew. Okay. So now, how do you figure this out? How would it look like? Well, the idea is similar with the hyperbola. With the hyperbola is that it needs to approach this. So, for example, like you see over here, there's this one, and there's the root. So the idea is that it has to go through that root, and then it has to approach the line. That's the idea of the slant asymptote, is that it's approaching, never touches it. Now over here, this one is gonna turn, and it's gonna, it will cross, right? So it will cross right here, and it will go down this way, but it has to be a nice transition curve, like that. So this is, and it will go down asymptotically. Question is what's going to be happening on the other side. Well, we need to know where the graph will be. So we need to pick something when x equals to, let's say, 7. When x equals to 7, f of 7 is, if you substitute in the original function, you'll get, let me just do this on my calculator, it's going to be 7 squared plus 4 times 7 minus 6 divided by 1. Well, I get a really big number, which is 71. Okay, so that means when x is 7, this is very up over there. Okay, and then it has to turn and start to approach the asymptote. So the idea is it's going to be somewhere here, and then it's going to turn. We don't know where it turns. That's the question of calculus, and then it's going to continue going that way. So complicated problem, but the problem here has different components. Okay, so when you study this, focus on each part. How do I find horizontal? How do I find the vertical asymptote? How do I find an intercept? And then do your best to see how can you connect all these pieces together. Okay, so this is what we call a slant asymptote. Okay, now let's go back, and then we have a few more problems left. So let me do question number 26. So question number 26 asking us to use the vertex and the intercepts to sketch a graph of the quadratic function. So here you got f of x equals to, this is a good difficulty problem, okay, expect that to appear in your test, something of that type. Let's find vertex and an intercept. Okay, to find the vertex we do negative b over 2a. So that would be minus 4 divided by 2 times 1. So that gives us 2. And then we're going to put 2 inside. So it's going to be 2 squared minus 4 times 2 times minus 5. So it will be 4 minus 8 minus 5. And that is minus 4 minus 5. That's minus 9. Okay. So let me just check that. 4 plus 8 minus 5. So it's 4 minus 8 minus 5. That's negative 9. Okay, fine. So negative 9, that's the y. Okay, so our vertex is going to be 2 comma negative 9. Now we need the intercept. So we're going to take this thing, x-intercept. Well, let's find first y. It's easier to do. So if you put the 0 inside, you're gonna get -5. That's your y-intercept. Your x-intercept, you set it equal to 0. So x squared minus 4x taken by 5 equals to 0. Is that factorable? So x, 5, 1, minus 5, plus 1, right? Okay, so x equals to 5 and x equals to -1 roots. So then we make a picture. That's -1 and 1, 2, 3, 4, 5. That's a 5. And then there's 0 minus 5. That's gonna be somewhere there. And then you have 2, -9. So 1, 2, -9. So I guess this is symmetric. So then you're gonna get your picture. Parabola going this way. It's going that way. That's it. So just first find the vertex, find your intercepts, and then just simply connect them in the form of the parabola. Number 29, does the graph represent a function that has an inverse? No, it's not, because it fails the horizontal line test. Okay, now if you can see it here. Okay, over here, let me just use a mouse. Over here, you see, if you draw the horizontal line, it's gonna touch it at 2 places. In order to have an inverse, for every x there gotta be 1y, and for every 1y there has to be 1x. So this will not have an inverse, because if you try to find an inverse, you will get a result that is not a function. So no, this one does not, because it fails the horizontal line test. Okay. Use the graph of f to draw the graph of its inverse. Well, it's going to be hard for me to do, because I'll have to redraw this. But let me just explain to you quickly over here. If I zoom in, I can't draw on this thing. So here what will happen is that you're going to switch x and y. So do it point by point, and then you can, well, let me try to draw this. Okay. Let me see if I can do this. So this is x, this is y. I'm going to just try to copy this thing. So this is where it crosses the y-axis. This is where it crosses the x-axis. That's 2, that's 1. Okay, and then it does something like this, and then it shoots up very quickly, and this just goes down also pretty quickly. So now if I want to find an inverse, I'm going to switch x and y. So instead of 0, 1, well, this is not 0, 1. This is left, right? -1. So this right here is -1, comma 0. So that means this will become 0, comma -1. And 0, 2 will become 2, 0. Alright, and then what happens with the shape is that the shape will be reversed. So in other words, your graph would look something like this. This will go that way, shoots up on the x-axis instead of y-axis. This will do the turn like it did on the y-axis, like that, and then it's gonna shoot down this way. And the idea is that the resulting picture should be symmetric to the line y equals to x. So this is how you do it. Okay, take your intercept, switch them, and then draw it exactly symmetrically to the line y equal to x. Okay, I'll do number 31. Okay, so 31, you got f of x equals to -2 x minus 1 and x plus 3 cubed. Use the leading coefficient test to determine the graph and behavior. Okay, so let's do the and behavior of this graph. So we need to look at the highest term. So as before, we're going to take each thing and we're going to select the highest factor for each of them. Okay, so it's -2 times x cubed. So that gives you minus 2x to the power of 4. This is even. That means it goes to the same direction. And that minus means it's going down. So the end behavior is down, down. Okay, find the x-intercept, state whether the graph crosses or touches. Okay, so let's go back. Let's set this thing equal to 0. So we got x minus 1 equal to 0, and we have x plus 3 cubed equal to 0. Minus 2 doesn't have an x, so it can't give you any factors, right? So we just disregard it here. So x will be equal to 1. Multiplicity is 1, crosses. X equals to negative 3. Multiplicity is 3, odd, crosses. Find the y-intercept. Put the 0 inside. And you get minus 2, minus 1, and 3 cubed. I just plugged it in. So that gives us 2 times 27, right? 2 times 27, that's 54. I check that. 54. So f of 0 equals to 54. So... oh, well, I'm already oh yeah, good. Time to plot. So f of 0 equals to 54. Pretty far up. You got 1 is one root. Negative 3 is another root. And the direction is down, down. So I don't know what it's going to do in between. We don't discuss that, but I know it's going to cross each root, so it's going to have some kind of parabolic shape. So maybe it's going to do like this. Maybe it changes shape somehow. And then eventually it's go down. Exactly. Not really that important, but realize that it's down, down, has the intercepts, crosses them all, and that's it. So that's something like that is fine with me. Okay, as long as you show me the end behavior, the fact that it crosses, then I'm good. And finally, the last problem. Okay, number 32. So you have f of x equals to x to the 5th minus 3x to the 3rd minus 40x. Okay, so in order for us to graph that, we need to factor this completely. So let's go ahead and factor that. Let's take the x out. So we got x to the 4th minus 3x squared minus 40. Oh yeah, this might be very difficult because this one has the 4th degree. So let's hope we can factor that. So x squared, 40 is 20 times 2, 4 times 10, 8 times 5. Here we go. Here's our 3, 8 times 5. So we're going to do it minus 8 plus 5, right? That gives us minus 8x squared plus 5x squared. That is minus 3x squared. Alright, now we need to be able to factor this. Now, the problem is that all of these are not nice numbers. They're not even. I mean, they're not perfect. So we'll have to just set it equal to 0 and just find all of those roots, right? Oh yeah, I forgot something. Let's go. We have parts, right? Part A, use the leading coefficient test. Okay, leading coefficient test, that's x to the 5th. X to the 5th is like x to the 3rd, so it's like our parent, down up. B, intercepts. Okay, so that's where we need to set things equal to 0 and touch cross. Okay, well, look. This equals to 0. There's only one of them. This right here, if you set it equal to 0, see what you're gonna get? You're gonna get x squared equals to 8. So x equals to plus or minus root of 8. Or x equals to plus or minus 2 root of 2 if you simplify that. These are two different roots, so the multiplicity here is 1 each. Okay, so it's just irrational, but multiplicity is 1. And this one right here, it's x squared plus 5. Oh, that's good. That's very good. because that is -5 and it has no real roots, and because we're plotting it, for us, we don't care about that point. F of 0 is 0. That's nice, because if you put 0 in, you get 0 out. And now if you plot this, let's see, we got 0, 0. We got 2 root of 2. I don't know what that equals to. You can use a calculator. Doesn't matter. -2 root of 2. It crosses each. And the end behavior is down, up, right? So I gotta start from here and ended up there. Okay, so let's do this. Something like that. Change, something like that. Come back. Oh yeah, and it's an odd function. I just noticed. Look at this. All of the powers are odd. So if you put minus or plus, they give you the same answer. So it would be nicely and symmetric to the origin. So it should look to the right and follow out the same. So this is what it is. Okay. Alright guys, so look over each of the problems there. Focus on the key concepts. And if you have any questions, ask me in class. Good luck.